just as an example of a non-trivial probability, when I am going to do a probability calculation over a non-aligned rectangle or over a non-aligned region. In other words, the aligned regions are easy because why are aligned regions so trivial to calculate, not trivial but very easy to write down, because x and y limits are numbers independent of each other. The x limits do not depend on the y limits, etc., and vice versa. So now let us look at this probability x greater than y. So x and y for what? Jointly continuous x and y. In this case, this is what I want to do. I want to do this calculation. I am going to straight away assume that they are jointly continuous. When they are jointly continuous, you know as an aside that probability x equal to y is 0. We already saw that sometime last week. Right? Probability of any line or any curve is 0. No matter what. Again, what is the physical intuition behind this? Right? In the case of independent x and y, the probability that you will get the same identical reading for two spinning pointers is very, very small, vanishingly small. If you, and there is 0 in the limit if you consider infinite precision. Right? Okay. So the partition on the xy plane, which corresponds to x equal to y, x greater than y, x less than y, now reduces to just x greater than y and x, what did I say, x greater than y, x less than y. You don't have to consider x equal to y, isn't it? So I have this, and I have this straight line x equal to y. So what does this region correspond to? You still have quite a bit of the day to go, so please wake up a little bit. So what does this region correspond to? X greater than y, and this is x less than y. So if I want to calculate the probability that x is greater than y, what do I have to? I have to integrate the joint density function over what region? This entire region using the extended definition. So we are asking the question, what is the probability that the point will occur here, that x and y will take some, right, some any point, right, joint value in here as opposed to here. To simplify the calculation, right, I will assume that x and y are independent. Consider also independent, not necessarily identically distributed, but just independent x and y. Okay, that's, but before, okay, so before we bring the independence, I can write the general expression. P of x greater than y is what is, so how do I integrate? So I start with fxy, xy. So even in the independent case, in general, this is not only true for independent, it is also true in general. I start with fxy. Let us say if I want to integrate some function over this region, what do I have to do? I can integrate first vertically and then horizontally. So if I want to integrate vertically, which is with respect to y, what will be the limits? We will assume that in general it is minus infinity using extended definitions of fxy and so on. It will be minus infinity to up to here. So I am freezing the x. Remember how to do double integration, right? You are freezing, you are integrating over one variable, keeping the other one fixed. So I am keeping x fixed and varying y from minus infinity to x only. So y will go from minus infinity to x, and then x in general can go from minus infinity to infinity. The most general case, it cannot be anything, there cannot be a case which can go beyond this. This is in general. Isn't it? Now let us, to simplify this, let us bring in the right, assuming that, let us assume they are independent. Of course you cannot proceed beyond this unless you know the fxy. but in some symmetry cases, as we will see, right. For example, in the darts case, what is this, it will have to work out to be what, half, right. Why? Because you can look at it by symmetry and say that the circle is nice and symmetric about the axis. So if I draw this line, right, it will exactly divide the circle into two parts, each with equal area, therefore equal probability. So symmetry should always be at the back of your minds. Right. But let me, I am taking this asymmetric case where x and y can have different PDFs, but let them be independent. Okay. So what do I get here? So this should have been here, right, but anyway I wrote it there, so we consider it written here. So this implies that fxy xy is is always a product of the individual PDS, the marginal PDS for all xy, no matter what. So therefore this probability of x greater than y becomes, let's rewrite the same thing. First write the integral on y minus infinity to y. The integrand I will split like this, dy, then I have dx, and then integral from minus infinity to infinity. Now what can I do with this integrand? I can pull out the fx of x, is it not? This can be pulled out. What is the inside? The inside, it turns out, is minus infinity to infinity. This is x, you can just, so automatically that will be y. So I have fx of x here. This integral of fy of y dy from minus infinity to y is, or minus infinity to x is what? Essentially this is capital Fy of what? Of x. So it becomes the CDF. So this is an interesting integrand now. It involves a combination of the CDF of the one and the PDF of the other. This is true, right? All you require here is, right, the x and y independent of x and y. You do not require them to be identically distributed. Of course, you can't proceed beyond this, right? You have to leave, you have to stop here because you don't know what. And obviously in the Gaussian case, for example, this does not have a closed form expression, so you may have to do numerical integration. All that is not, is a case by case basis kind of thing. But for the exponential case, for example, where if you do exponentials and stuff like that, remember the limits will have to be appropriately adjusted. It will always be 0 to infinity and not minus infinity to infinity. You can, so you are if you're looking at two exponential random variables x, right, with lambda 1, lambda 2, you would have to forget about this part of the plane and only integrate over here. But the 0 to, so the 0 to x will also be, this will also give you 0 Fy of x only. The only thing you have to remember is this x is positive, not negative. But you have a closed form expression for this and this, and the integral you can do by yourselves, isn't it? So please brush up all integration, right, especially the exponential for simple things. But here, supposing I take the IID case, now, right, I have said they are independent. Now to make it even simpler, supposing now I want to bring in one more restriction. I want to say that they are IID. For IID, what happens is this Fy of x becomes what? Supposing I just want to look at only x. Fy of x is identical to Fx of x.
So the second integral upper limit is x.
Yes, sorry about that. Yes, you are right. Oh yeah, here. It's okay. I mean, as usual, always talking and writing slips are possible. Thank you very much. Okay. Yeah, you are right. Obviously, there has to be x. I wrote it correctly here. That's what matters, right? The first thing has to be correct. Second thing, I am allowed to make a mistake. So, supposing they are IID, now what happens? Fy is the same as Fx for all points. So, this will become, if I change this to Fx of x without, let me do it this way without any erasing or without any right, without writing it again. No, it's we are not let's not jump ahead of ourselves, right? Not doing expectations. But this integral, it turns out, is evaluatable no matter, even if fx doesn't have a closed form, because this is the derivative of this. So what is the integral going to be? The indefinite integral is half of fx squared. So what is the value of this? This is, what is the value of this? Half, right? Does everyone see this, that this is the derivative of this? So when you have this, the derivative, and I mean multiplied by the function, the product of the derivative of this is always the integral, the indefinite integral is this. If you have a difficulty, just differentiate this, you should obviously get this. So this is exactly 0.5. Why does this result make perfect sense? This is a symmetric case, this is 0. So in the symmetric case, you have obviously exact same probability for x greater than y and x less than y. So now, am I seeing some more, a little bit of more spark here? That the maths is actually tying, whenever the maths is consistent with intuition, we really we have a new, right, respect for the whole thing, don't we? It's exactly what we get by symmetry. Right. So in general, of course, if an x and y were not if they were not ID, then you would have y, this would not be the same as this, and you cannot proceed unless you know the exact distributions. You can proceed only if you know the form of this and this. In the Gaussian case, for example, you could not evaluate this in closed form because you don't even have an expression for this in closed form. You only have this, you don't have this. So you would have to do numerical integration. Have you done numerical integration for in any course? I guess probably not so far, but if you take any computational engineering course, the first thing they ask you to do is do numerical integration. Right? So this also you can think of as examples of numerical integration, very, very important examples as far as we are concerned. Unfortunately, we don't have the bandwidth in this course to send you off on a hunt, right, or evaluation of these things. So I just have to point out what you'd have to do and leave it at that. So if you ever need to do it, you know what to do. So don't be shy to numerically integrate, numerically evaluate, isn't it? Okay, so anyway, so this, I think more examples of probability calculations like this for dependent or independent. I think it's you got the general drift, right? Instead of taking some funny example which doesn't end up with any intuition like this, I can always look at some region. So the more regular the region, here the region is really nice and regular because it's still triangular. If the more irregular you make the region, the more complicated it is to evaluate the integral.